All right, so a review of last time really quickly. So we talked about triangles, right? We talked about some proofs. I'm not going to review the triangle congruence theorems with you. You know them. Side, 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 angle, right? None of them spell ASS, right? Forward or backwards. That's simple. HL is only for right triangles, hypotenuse, leg. Don't need to review that. What I am instead going to review is this. So here is your warm-up for the day. I know we're kind of out of order for this, but here's your warm-up. So I'm giving you a triangle, right? And I'm extending this side right here out. And I want to know what the length of this is, or not the length, the angle measure of this, if I give you that this angle right here is 45, and that this angle right here is 25. Do that now. I want to know what that external angle is given these two internal angles.
This is what we're doing. This is what it means.
And it's so easy. I know.
I got it.
Mr. Samitas, please stop talking. You don't see this triangle below. You totally don't. Work on that now. Work on that now. All right, time's up. I need somebody to walk me through this one. Walk me through it. What did they do to solve this problem right here? I need a hand. I need a hand. Samitas, the younger.
Hi.
Everybody listen.
So in order to find the angle that we have to find, you have to figure out the other angle inside the triangle.
So you need to figure out this angle right here.
Yes. And in order to do that, you need to, since a triangle has 180 degrees inside of it, you have to add 25 and 45 and then subtract that from 180.
Gotcha. So 25 plus 45 is?
70.
And we subtract it from 180 and we get?
110.
110 degrees, which means this angle must be what?
Well, since it's a linear pair, according to the linear pair theorem,
Yeah, boy, get it.
could
Yeah.
it be like 70 degrees?
That's exactly 70 degrees. Well done. Guys, so his logic is this.
Look at going go.
The internal angles of a triangle, the interior angles, all add up to 180. Therefore, this has to be 110. I hope everybody's seeing that. Then he's saying, because this is on a line, these two angles are a linear pair, because they're two angles on a line. And linear pair theorem says that if two angles are on a line, they have to add up to 180. So if that's 110, he got to be 170. Nice job, Mr. Samitas. Well done. So that's 70 degrees. Now, what's another way to do this?
Just add 2.
What's up, Natalie? This one right here? Yes, this angle right here is 70. Yes, Natalie, it is 70. So Natalie and Marcus had the same idea. Marcus and Natalie both know that the exterior angle is equal to the sum of its remote interior angles. So what do I mean by that? Remote interior angles. Mr. Sawyer, welcome back to class. Could you tell me what interior means?
No.
Try again. The inside. Thank you, Mr. Sawyer. Funny as usual. Just as funny as Preston's repetitive humor. Interior. These two angles are on the inside, but so is this one. The key word here is remote. Remote meaning what? Who can tell me what remote means in this context? Carson. Does it matter? What?
It doesn't matter.
That's not what remote means. Mr. Sawyer, you are now the second funniest person in this classroom, just ahead of Preston. All right. Sorry, least funny. Second least funniest. Sorry, I said that incorrectly. Remote. What does it mean in this context? Remote. Clara. She doesn't know. Can someone help Clara? Clara needs help. Scuday. I doubt it. Marcus. Far away. Far away. So, a remote angle is a far away angle. Now, there are two of them that are far away from this exterior. Here's the exterior. The closest internal or interior angle is this one. The two remote ones, the ones that are far away, are these. And Natalie, what do we know about remote interior angles? They add up to what? These two should add together to 70. So they add up to the exterior angle. So if you find an exterior angle, this guy right here, and you look at its remote interior angles, these two right here, if you sum them, add them together, you get the measure here. 45 plus 25 is 70. It's just really another way of saying that 45 plus 25 minus 180 is 70. 45 plus 25 is going to be that missing difference. So it's kind of a silly theorem. Let's take a look at the next one. I give you this. Solve it. Find the missing angle right here, that exterior angle. Do it now. Do it now. Shh. Be less loud. Oh, one of those? Yeah, you can do that. Not these, but...
I got the answer. You have one piece I have the
What can't X be? I don't know. I'm about to go over it, so you can check your work then. All right, here we go. So somebody walk me through their thought process. I need a hand here that isn't Mr. Magden, who has already received enough extra credit for his effort.
What?
Nah, just kidding. I don't give extra credit, but man, it got your attention. Who's going to help me out here? I need somebody. Bailey? No, it's okay. Being right is not the goal here. I want to hear your thought process. Yeah. Yeah, there's some connection between the sides and the angle. Exactly. So, the key here is that this is what kind of a triangle? Isosceles, which means two sides are the same. So, if the sides are the same, the angles are the same. So that's a 75-degree angle, which means if we add those two together, we should get this guy, which is what?
150.
$1.50. That's right. Another way to do it was to say, well, I know those two angles, and then therefore I know this angle. What angle must this be? If I subtract 150 from 180, I get 30 here. Cool. Wonderful. Many ways to solve it. Next question for you. Next question. If I were to extend this out to here, I want to know, what's the angle measure here?
I know it.
Who can tell me the angle measure of the light blue? Mr. Smeetus.
Wait a second.
Yeah,
No, is it a straight line?
it is.
That's 180.
180 degrees. It is a trivial exterior angle. Anytime we extend them, we get trivial angles, right? That's 180 as well. We did. It's a quick review. A warm-up, if you will. This angle right here is going to be what? That's a non-trivial angle. What's that going to be, Mr. Smeetus?
No, wait.
Yeah?
105.
105. How did you discover that, Mr. Smeetus?
Because I did what we did before, and that is when you get 180 and you subtract it by the other angle.
Got it. So he says this is a linear pair, so if I subtract 75, I get 105. The other way to do it is to add these two remote exterior angles to get this guy. Easy peasy, lemon squeezy. All right, so that's the deal with exterior and interior angles. Let's do one further. My question for you is this. The sum, listen to my words, listen to my words. The sum of the interior angles of a triangle is what? I need a hand. Carson. 180. The interior angles, the inside ones, Mr. Sawyer. The sum of the exterior angles is what? I need a hand, I need a hand. Yes, Mr. Dively. 360 is correct. They add up to 360. Here's a regular polygon. Regular meaning all the sides are the same and all the angles are the same. What kind of a shape is that?
Oh, that looks like a
Hexagon. Hexagon. Hexagon has how many sides? 6 sides. So a 6-sidagon, right? So it has 6 sides. We know that a triangle's interior angles sum to 180. What about the interior angles of a hexagon? I want somebody to prove to me that the sum of the interior angles of a hexagon are, let me do some quick math here, 720 degrees.
really?
Work on that. I'm going to give you 5 minutes. Prove to me that this is 720. My first hint to you is this. That's my first hint. That's my hint. I want you to be able to prove it to me. A visual proof. You do not need to write it. You just need to show me why it has to be 720. Best of luck to you.
This is the first time I'm being able to write the words, though.
Do what you can. I'm going to give you 5 minutes to work on it.
Wait, we were only writing words.
No, you can write however you want. You can just draw a picture, but I can't think of a picture to draw.
And if the talking doesn't get less, we're going to take our quiz now. Thank you. Your song of the day is...
Is this our daily?
Yeah, sort of. Kind of. Not really. I just call it a little warm-up. It's called Hooked on a Feeling by Blue Swede, which you've probably heard from, I believe, Guardians of the Galaxy is what I was told today. So here's a funky little groove.
I got it figured out.
I'll get you to the end of the song and figure it out. Time is up. So I was kind of feeling by Blue Swede. A play on words, Blue Suede. A one-hit wonder. All right, so although he did go on to work with some other artists and make some bigger hits. I can't remember who. I want to say the Bee Gees, but I know that's not right. All right, so check it out. Some of you already figured it out. If we divide this up into triangles, how many triangles did I draw? 4 triangles. So 4 triangles, and each triangle has 180 degrees internally, right? So 4 times 180, 720. Boom. So now I'm going to ask you this. I'm going to tell you that's a regular hexagon. I know my drawing isn't very good. Hexagon has how many sides? 6. Okay. That's a thing. Okay. These are all triangles, says me. Okay. Triangle, 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 triangle. How many triangles do I have? 6 triangles. So 6 times 180 is what? 360 plus 720. 1080. So same thing. Same thing divided up. This would say that, hey, the interior angle should all add up to 1080. My question for you now, and I'm going to give you a minute to do it and think about it. Why is this wrong? Because, again, we broke this up into triangles and we got 720, which is the correct answer when you sum all these up. Why does this get us a different answer, and why is it not right? I'm going to give you a couple minutes to do that. So think about it. Discuss in your groups, if you will. Discuss. I want some explanation from each group. The song that we will listen to while this is happening.
I don't know. We've been off guard today. I don't know.
Will be Good Day Sunshine by the Beatles. From their Revolver album, which is another name for it. So that's the end of Good Day Sunshine by the Beatles from their album Revolver. This is a chicken sandwich that isn't really chicken. Nando's. Delicious. What, Natalie? Explain to the class your findings. Oh, Natalie has a question. Everybody quiet. All right. Somebody tell me. Someone solve this. words. You're a freshman too. Get over here.
Okay, but there's
He's
the
at
most
the
of the
cool kitchen.
freshmen over there.
Marcus, you're a freshman? I didn't realize that.
I'm a
I
freshman.
thought most of you were sophomores. Oh, good lord.
I'm a freshman. Hey,
I knew I hated the freshman class. Alright, so who can explain why if we divided up one way we get the right answer, and we divided it the other way we get the wrong answer? Nobody? Josephine.
Joey's got it.
Joey, explain. Right. So she's saying that this way of dividing it up gives us central angles. And Preston, what are those central angles all going to sum to? Those are all going to sum to 360 because they are a revolution. A revolution, right? So, 360 degrees. This one does not have any central angles. It cuts them out. And we don't want to know about the central angles. We only want to know about the outside angles. So if you add up all these triangles and you get 1080, and you subtract the central angles, what do you get? 720, the correct answer. So you can remove all of those. And you get the outer angles. So that's pretty dope. Last question for you. What shape is this? It's a stop sign octagon. Like MMA. Alright, so I want you to take the octagon and divide it up into triangles that don't have any central angles. Divide it up like we did this one, with no central angles. Do that now. I'll give you 30 seconds. Into triangles. That's the one with the 3 angles and the 3 sides?
I was thinking it was 4.
Yeah, common mistake. And make sure there's no central angles. Just to be clear, this is the wrong solution. This is the wrong solution. These have central angles. I want you to divide it up like this, so there's no central angles for your triangles. Yeah, they can't go through the middle. See how this one has central angles and this one doesn't? Yeah, we don't want that. That's okay. That's good. We don't want the thing to go through the middle because that produces central angles. If we do through the middle, then we get a bunch of central angles, and we don't want those. I'm sorry, Natalie.
Yeah, I did it. Okay, I'm gonna.
5, 4, 3, 2, 1. Somebody get up and point to the TV screen where I can see you, and I will draw in the way that you did it. Somebody, anybody. How about Miss Scuday, who's had 2 large coffees this morning from Dunkin'?
Correct.
All right.
Can I give you one next time? Anywho, I went from here to here, and then the same on this side, and then from here to here to here, and then I made that into a triangle, or 2 triangles.
So like this.
Yeah,
Okay, and how many triangles do we have?
6.
1, 2, 3, 4, 5, 6. 6 triangles. And how many angles altogether do we have for 6 triangles? 1080, which is the correct answer. Well done. That's one way to do it. See you after lunch. Yeah, I wouldn't have done it that way. That's a weird way.
It was kind of close.